Hi, everybody. Thanks for coming out. I'm Carl Meadows. I am product management for Amazon Elasticsearch service. So my job is to give you a little context about the service and about what's going on in the market before I turn it over to Kuldeep, who'll go into the deep dive on the really interesting stuff about what Expedia is doing with their log analytics with Amazon Elasticsearch service. So as you all probably are aware and are seeing in your own S3 bills, that amount of data being generated is growing a lot. And what's driving that data? It's important to kind of think about what those key drivers are to decide if this is a trend that's going to continue or accelerate. And the fact is that machine-generated data is driving most of that. So business data is growing, but when you look at machine-generated data, it's growing at 10 times the speed of business data. And there's several factors, and some of these overlap, and there's probably other factors as well. But if you think about the trend that's changed from IT centralized ops to a more DevOps environment, you'll see that developers are very intimate with their code. And if I'm a developer and I'm responsible for supporting my apps, one of the best ways I can provide myself with information is by putting it in logs that I can get access to. So that means a lot more logs, as developers are responsible for writing more of their own code, or supporting more of their own code. On the other side, we have a huge proliferation of devices. And I don't need to talk about that, everybody sees it. But all of these devices emit data, be it metrics or small logs or statuses. And that data is very valuable. And then there's a shift to more cloud-based architectures as well, be it microservices, or just needing logs to troubleshoot what's going on in your environment, be it VPC flow logs or ELB logs. Since you don't have access to the physical equipment anymore in the cloud, you rely on logs a lot. All of that is generating lots of data. So much so that it's driving a huge demand for an open source solution to this problem for how do I analyze that data and get value out of that data and quickly understand what's going on. And there have been commercial solutions out in the market the great commercial solutions for analyzing logs and machine-generated data. But with this explosion in data and the continuing explosion of data, those get very expensive. And thus the value of an open source alternative starts to become extremely attractive. So much so that in a recent study by TechCrunch, had Elasticsearch all the way up at number 7, above such hugely important projects as Spark and Mongo. And the reason is that, like I said, Elasticsearch has taken the mantle as this open source solution to this problem. It's become sort of the de facto standard for how we do log analytics and machine-generated analytics. It's very fast time to value. It's got very easy ingestion. It's got an easy visualization tool, which is Kibana, which is a sister project, and high performance distributed. And it's a great solution for both analytics and full text search. So let's start with just a quick definition for those of you that aren't familiar. Most of you probably are. Elasticsearch itself is a search engine that's powering this log analytics. But there's two other projects that are often talked together when we refer to the ELK stack. Often there's other more modern names as it's expanded, but Logstash is a very lightweight transformation tool and data pipeline for getting data into Elasticsearch. There's a number of ways to get data into Elasticsearch. Kuldeep's going to talk about several that they use at Expedia. But Kibana is also an essential element of this when it comes to log analytics, because Kibana is a visualization tool which allows me to build my dashboards and build my charts and visualize the data that is in my Elasticsearch cluster. So Elasticsearch is an extremely versatile platform. So we see it being used in a number of ways. Today we're primarily going to talk about log analytics, but which would mostly fall in the application monitoring and root cause analysis bucket here, which is providing developers with the data they need to analyze what's going on in their environment in real time. But it's also often used heavily by security teams for getting all of that same information together, but for a different audience and for a different need, which is to try to identify malicious or potentially suspect activity in my network or in my applications. IoT and mobile, we've talked about that. That could be time series, it could be geo-based, and it could also just be log data as well. And then business and clickstream analytics, because again, it's getting all of this machine-generated data. It can be a very good solution. We see a lot of customers using it for analyzing e-commerce platforms and funnel analysis. But today we're going to talk about log analytics. And so the service that Amazon provides that takes this open source project Elasticsearch and Kibana is the Amazon Elasticsearch service. It's fully managed. It makes it very easy to deploy and manage and scale Elasticsearch and Kibana in that package. I'll quickly go over the benefits before I give it over to Kuldeep. So it supports open source Elastic out of the box, so it's a drop-in replacement for self-managed Elasticsearch. Extremely easy to use. You've got from a single API or a few clicks in the console, you can have a cluster up and running with complex configurations. It's easy to scale. Same thing. If you had a small environment with 3 nodes and you need to scale it up to 100 nodes, you can do that with a single API call, completely changing out your storage and instance classes without any downtime. It's secure. It integrates with VPC, integrates with IAM, allows you to use security groups as well as IP and IAM-based policies to secure access to the cluster. It has high availability features, including spreading your clusters across multiple zones, handling the replication for you with our zone awareness feature, and self-healing. And it's like the other Amazon services, it's tightly integrated. It has support for CloudWatch, for CloudWatch logs, for Kinesis Firehose, Lambda, all of the services that you guys regularly use are tightly integrated with it. The other point I would make is that Elasticsearch isn't really, it's good for pretty much any vertical or any segment, as well as companies of all sizes. So we've seen customers from a hugely diverse array of industries have a lot of success and adopt this product. And the open source technology underneath it as well. And so with that, I'd like to turn it over to Kuldeep to really get us into the meat of this and talk about what Expedia is doing for their log analytics platform.
Good afternoon, everyone. Thanks, Carl, for the overview of what is an elk stack, how it is helping businesses understand that machine-generated data, and then also giving an overview of the benefits that Amazon Elasticsearch offers. I'm Kuldeep. I'm from Expedia Inc. Expedia Inc. has some of the world's prominent travel brands like Expedia, HomeAway, Hotels.com, Travelocity, Orbitz, Cheap Tickets, and many more. We have more than 200 different websites in 75 different countries. We have about 150 mobile sites in 35 different languages. Again, some tech stats for the techies here. We do over 1 billion searches per day in our lodging, pricing, and availability stack. It does about more than 1 billion searches a day. We have our own data centers, but we are also actively trying to migrate to AWS. Some of our infrastructure is already there in 5 different Amazon regions. And again, we are continuing to migrate to AWS. So what I'm going to talk today are 3 things. Our usage of Amazon Elasticsearch service. Why did we choose Amazon Elasticsearch service? And then I'm going to talk about 5 different architectures of how we are using Elasticsearch service. Our current usage is about 150 clusters of Amazon Elasticsearch service. Again, I represent brand Expedia side of things. We have a lot of other brands as well. And what I'm talking today is specifically geared towards brand Expedia. And this 150 clusters, they are across 3 different Amazon accounts. Again, we do it today by security context, like prod, PCI prod, or test. And we are also looking at segregating or segmenting our accounts into a lot of smaller accounts, if you will, by lines of business or whatnot. And these clusters, they vary from different sizes. Some of them have T2 medium, some of them have I2 8 extra large instances as well. It's just a whole big mix of clusters that the teams use across brand Expedia. And we have about 450 nodes that are powering all these clusters. And the amount of data that is there in these clusters is about 30 terabytes. And out of these 30 terabytes, about 8 to 9 terabytes are just within 3 different clusters. And the amount of data that they store is only for 3 days. They don't store data more than 3 days. Again, I'll talk about the benefits where if we have to scale it later on. And then we do about 30 billion documents across all these clusters. I think the bigger question, there is, I think as Carl mentioned, there is open source version of Elasticsearch, which you can go and install on EC2 instance. And that is what we used to do actually before even Amazon's Elasticsearch service came in. Before we had EMR, we have EMR and data pipeline jobs that we run. And to analyze the logs that are generated by EMR and data pipeline, we built our own like elk stack, which uses Logstash and go and gets the data from S3. And then, because the interface that S3 provided was not better for like full text searching, if you will. But the problems with that approach was we were able to automate creation of a node, like one node at a time, but we were not completely, we didn't completely automate the full cluster creation. It was like semi-automatic, if you will. And then when we had to actually scale our cluster, it was again the same drill we have to go through, create new instance and add it to the cluster. So it was always the same thing over and over. Very high level, the biggest benefit, it's pretty easy to set up, right? Like you go to the console, enter few information that you need, select the instance type that you want, select the number of masters that you want, and then boom, it creates. What you are seeing here is not the Amazon's Elasticsearch service UI. This is our Jenkins like build job, if you will. So the reason why we have our own build jobs here is we want to make sure the clusters are tagged with proper like nomenclature, and so that we can do bookkeeping and also do showback or whatnot. Behind the scenes, it just uses Amazon's APIs. If we don't use any other tools here to interact with Amazon, but it is just an additional layer on top of it. Again, I didn't list that part of the tags, but this is what helps us to make sure that there is enough governance on these clusters. And as I mentioned earlier, the biggest benefit that you get with Elasticsearch service is the high availability aspect, right? This is again Amazon's Elasticsearch service console, wherein this is a screenshot of an existing cluster that we have. As you can see, we have dedicated masters, and there are about 12 nodes in the cluster. And if I want to change something, I can just change the number here. I can change the instance count. I can change the instance type, and then boom, I can make the changes, and then changes will get reflected. Security, which I think Carl mentioned earlier, there are varying levels of security that Elasticsearch provides. What you see here is a typical security policy or access policy that we apply for all of our clusters. Again, I have simplified it a little bit. Ideally, what we are doing here is for every account that we have in this AWS account, we are giving access. And also we have different IPs where if people want to use Kibana dashboard, we whitelist it to our office IPs. Of course, our office IP is not 0.0. But you can customize however you want to. But this is typically what we apply to all of our clusters. And people will go and change it. The other thing, flexible storage options. It provides instant store, like some of the instances in EC2 has instant stores, which are really, really high throughput volumes. And then you also have VPS. So you can choose between whichever you want to. And then the biggest is here monitoring, right? Like where it is integrated with CloudWatch. You can create an alarm if you want to with the CloudWatch alerts. Or you have the opportunity to even have a Lambda invoke to go and change the instance type. We haven't done that, but you do have the opportunity to go and do it if you want to. And then the backups, which we never had to use it, but there is always this peace of mind that you get that there is a backup that's available for whatever reason the cluster goes down or the data is corrupted. Yep. So this is where I'm going to talk about 5 different architectures that we have, that we are using Elasticsearch service at Expedia. Again, this is spread across a lot of different teams in brand Expedia. This doesn't cover all the different types of architectures that we have. And the reason why I have different, like 5 different ones than one is my aim was to go more horizontally or breadth-wise than going deep into one of them. I'm happy to answer questions after the talk, but the intention is to go horizontally across a lot of different ones. The first one, Docker startup logs to Elasticsearch. About 2.5 years ago, we started our journey to move from EC2 instances to using ECS. So we use ECS heavily within our infrastructure to deploy our Docker containers. And then we started deploying our services, creating our microservices, and then deploying them. After a while, we had this issue where, for whatever reason, when the Docker container is starting up, the log is just written to the console. It is not written anywhere else. Our existing log management solution until then was by basically looking at a file on the disk and then pushing that data into its log indexer so that we can go and do our search. But with this Docker only writing to the console, and then again it runs in its own sandbox environment, if you will, it was very hard for us, not for us, but for the teams to understand why a particular service is not even starting up. Once it starts, when it starts writing the logs used to flow to our log management system and people used to go and stream. With Docker 1.7, Docker introduced something called as a log driver as an option, which is basically a streaming option, which can stream your logs into like different types of plugins were offered. When it came out, the log management solution that we had did not provide that log driver option yet. So what we did was we used Fluent for this purpose and then Elasticsearch as well. I'll walk through the architecture and then talk about some of the configurations that we did to get it working. So what we did, again, we used ECS. So ECS has its own agents, if you will, on each of the host instances, and then it also writes logs for whatever the ECS agent has. So we configured ECS agent to write the stream the log information to Fluent, and then we did the same thing on the Docker containers, saying anything that you log to the console, just stream it to Fluent. Again, I didn't talk about Fluent yet. What Fluent provides you, it unifies data collection between like whoever is producing it and whoever is consuming it, so that the data sources, whichever are generating the logs, doesn't need to know more about who is going to consume it. Fluentd is similar to Apache Flume or Facebook Scribe, if you know those systems. What we did is we set up Fluentd clusters in all our environments in all the regions, and then we also set up Elasticsearch clusters. So on Fluent, when the logs were written to Fluent, it was just forwarding the logs that came to Fluent directly into Elasticsearch. And then once the data is available in Elasticsearch service, people used Kibana to go and do a search of their Docker container why it was not starting up. So what we did to close the loop here was, whenever a service doesn't work, like doesn't get deployed into the AWS environment, we send them a URL for the Kibana dashboard or Kibana search with the proper service name and the tag, so that they don't even have to go and search that query, but they can, when it opens up, they have the logs in front of them. So that is how we solved one of them. Very high level, on the Docker side, this is how we configure, right? Like this Fluentd here in the brackets is the Fluentd cluster in that particular region, and the tag here is the Docker containers tag. You could have your own tags, but that is how, when we go and do the search, we are able to search saying that for this Docker microservice and this particular version, give me the logs. This is on Fluentd, basically what we are saying, anything that you get, just forward it. And the destination for forwarding is the Elasticsearch domain, right? Like we created an Elasticsearch cluster in each region, so anything that came to Fluent was just forwarding there. So this is one of them, and then the second one that I wanted to talk about was how we use Cloud Trail data, and then using Elasticsearch, what problems did we solve. Very high level Cloud Trail, it gives you all the API calls that are made in your AWS account and then deposits those records into a S3 bucket. You can do a lot of different things with that log files because it has the who made that API call, what was the source IP, what time, there are a lot of information that is available in this. The AWS console for the Cloud Trail it doesn't record all the events, so we needed a way to go and actually parse that log. You can use it for different purposes. Last year we were actually using to go and tag our volumes whenever an EC2 instance spun up, because there was no option to go and automatically apply the tags that the EC2 instance had onto the EBS volumes. So we actually use Cloud Trail data to do that. You can use it to, I think as Carl mentioned, you can do for security as well, because if you know the source IP and you have a limit of source IPs that you are only allowed to make those API calls, you can flag. There are a lot of different possibilities that you can play with. So the problem that we were trying to solve with this was, as I said, we have like 3 different accounts and a lot of our infrastructure is in this 3 different accounts. For most part of, I think we were getting throttled on ELBs, on ECS, on EC2 as well. We were getting a lot of API throttled requests. So we wanted to know who is actually making those calls and which IAM role or which IAM user was making that call. And we actually were able to solve that with the architecture that I'm going to show right now. So what we did is we created a Cloud Trail. It's like, again, in Cloud Trail, it's called as a trail. You create a trail to say for all the regions, go and deposit the logs into an S3 bucket. And then once the data is in the S3 bucket, you can configure it in multiple ways, right? Like on the Cloud Trail itself, you can say whenever you write the S3 file, just do an SNS notification, or you can do that on the S3 bucket itself. You pick whichever option you want to, but I recommend doing it on the Cloud Trail than doing it on the S3 bucket. And then once an event is triggered on SNS, we have a Lambda that listens on this SNS event, and what it does purely is go and read the data from S3 and then just deposit that data into Elasticsearch. It doesn't do any transformation, no decoration, nothing. You just go and read the data from S3 and deposit it. And then once the data is in Elasticsearch, we were able to create different dashboards. I'll show one of the dashboard in a minute. So that was a very easy way for us to get it to identify who was making those calls. Very high level, this is like as I mentioned earlier, you create a Cloud Trail, you say, hey, write this to an S3 bucket, and then you can do a publish to SNS here itself, and then it shows you the topic, and on SNS, on the Lambda, you can configure to listen on this SNS topic. This is all the code that we have in the Lambda. Just go and read it from S3, and then once the data, it's stored in ZZip format, so you unzip it, and then just write to Elasticsearch. That's all it was doing. And then once the data was available in Elasticsearch, we created this dashboard that told us, hey, for the last 10 minutes, these were the top 10 API calls. Right? I am not showing another dashboards that we have because of the IAM users and whatnot, but very high level, this is, and one of the things that I think we provided the feedback even back to AWS is some of these calls that you see here are actually AWS generated calls, not user generated calls. Example, when you're using ECS with ELB, ECS makes a lot of calls to ELBs because the way that is integrated. So, but again, this provided as a way for us to have a dialogue with AWS to say that, hey, these are the calls that are being made and who's making the call. So the entire solution that I showed earlier, sorry, I have to go back. The whole solution that I'm talking here, I have open sourced it in this location. So it's a completely serverless application. Once you run it using Amazon SAM, you'll have the Cloud Trail created, S3 bucket, SNS notification, even the Lambda code to read data from S3 and write it to Elasticsearch. It's all done. You just have to run that SAM or like serverless application model from AWS. In that location, you can also see our existing open source solutions that we have done and some of the new stuff that we are working on. And the next one that I'm going to talk about is how we use Elasticsearch in our CI/CD platform. The CI/CD platform that we use for deploying our services to AWS is called as Primer. And then I have spoken about Primer at a different AWS topic conference already last year. We have created more than 4,000 different microservices using Primer. And out of them, I would say more than 1,000 are running at least have deployed once in production. We do about 1,500 deployments a day in all environments. Production probably around 300 times or 350 times. The problem that we had is with the massive adoption of this system, we always hit this this issue of why a particular deployment is failing. Is it because of the system issue, like when I say system, the platform issue, or is it user issue? When I say user, the whole platform is built on conventions, right? There needs to be few endpoints so that the system knows that, hey, your version is supposed to be the same version. Is it active? So if you deviate from those conventions, the system will start failing because that is how the system has been built. So we had to figure out a way to isolate whether it's a user-generated issue or a platform issue itself. So our platform is built with both Ruby and Node.js, and both of them actually they send notifications to SNS. Some of the types of notifications that we send are like deploy events or release events. And once these events are in SNS, we have a Lambda that actually gets triggered, and then what the Lambda does is it actually filters the events, decorates the events, because we don't want to capture all the events that are happening. Even though there are a lot of events that are being sent to that one SNS topic, we actually do some filter and then do decorates, and then we push them to Elasticsearch. And what we did is we built a Node.js application which basically uses Elasticsearch SDK, like Node SDK, and does a query onto Elasticsearch to get the data. Very high level, again, this is not exactly the query, but very high level, the query looks something like this, right? Like what we are saying here is between this start date and this end date, give me all the records which are with the tag primer KPI, and then do an aggregation based on the day and also based on the status. The status, what I mean here is like success, failure, or aborted. It could be different other status as well. And the Node.js UI, again, this is just a sample UI, but this is what is basically querying Elasticsearch. And the Elasticsearch is returning the data, and then we are just plotting this chart, which shows the number of deployments that we are doing. Looks like we are doing 2,000. I was wrong earlier. So that's how we were able to solve this use case. And if you see in the bottom, there are different types of filters that teams can do. You can actually do it by the user-generated and platform as well, which I'm not showing here, but that data is also available. So this is one of these clusters that I mentioned earlier, which has about 6 to 7 terabytes of our data out of the 30 terabytes. Very high level distributed tracing, as a lot of companies are moving from monolith architectures into microservices. You need a way to trace how a particular request is traversing through your system. What I'm showing here is just a Zipkin UI. Zipkin is a distributed tracing system that has been open sourced by Twitter. But again, this was also built based on Google's Dapper. Just search for Dapper. Google talks about how to do distributed tracing and whatnot. And then recently, I believe Airbnb also open sourced their distributed tracing called as Jaeger. And we are building our own version of it as well to fit our needs. But most of them, if you will, are based on same Google's Dapper framework. We're also looking at moving to open tracing to doing our tracing. Very quickly, to get you oriented, there are two important things within a distributed tracing system: a trace and a span. A trace typically is the time that it is taken to complete a complex web request. Sorry. Example, the top one could be a full-blown trace. It's basically calling different endpoints, different other microservices to get some things done. Or it could be just a simple get call as well, which doesn't need to have any children call, or if you will. Within a trace, you do have spans. Span actually is represented as the logical unit of work that is done within a trace. A trace can have multiple spans or a single span. It depends on what type of operation is being performed. So again, I just want to give that high-level overview of a trace and a span. What we did for this distributed platform and how does Elasticsearch fit into picture here. So we created a JVM-based library that most of our stack is Java heavy. So we created a JVM-based library, and that library is being is used by all these different microservices. And what this library does is it generates for each of the HTTP requests that's happening. It creates a trace. It creates a trace and then uploads that data pushes the data to Kinesis. So for all the microservices in different environments, all the data is being pushed to Kinesis. So we have a Java app that listens the data that is being streamed to Kinesis. It pulls the data from Kinesis, and then it does some transformation on the data that is there in Kinesis, and then pushes the data to Kafka. You could ask, why do we have both Kinesis and Kafka here? Kinesis becomes really, really expensive when we have multiple consumers of the data. Here what we are doing is we are pushing all the data from our different microservices to Kinesis, and then we have one consumer that is reading the data from Kinesis and writing to Kafka. But there are a lot of consumers of the data from Kafka. And Kafka is something that we have already, the Kafka clusters are something that we have already created within our ecosystem for a different use case, not just for the distributed tracing aspect. So that's how we have both of them running. And there is one more app that actually reads that span data that I talked earlier from this Kafka infrastructure and then pushes that data into Elasticsearch. So when I say pushes, what it pushes actually is the metadata of the trace. Like a trace could say, example, what service it is, what website ID or we also have some partner ID. So it has a lot of, you could have a lot of metadata for each trace. And what we store in Elasticsearch is just the trace, the metadata. What is the actual trace goes and is stored in a different data store. It is not stored in Elasticsearch. And then we have a UI that reads that data from Elasticsearch. And once we read the data from Elasticsearch, it goes and queries the other data source to retrieve that trace information and then store that information, display that information on the UI. Again, I just listed as a sample document here of what is actually stored here. Just one transaction ID. Again, this transaction ID could link all the other spans that we have, or all the spans that a trace has. How do we use it? Example, as I mentioned, a transaction log can have time, start time and end time. So if you want to filter the traces given a start time and end time, that's where Elasticsearch helps us. We first make the call to Elasticsearch. Elasticsearch generates that call, tells that data, and then we use the data to go and get the data from a different data source. And the last architecture that I wanted to talk very quickly is how we use Elasticsearch in our lodging or hotels. Again, this is primarily geared towards our images or content. So all the metadata for a given hotel image is actually stored into Elasticsearch. Some of these are the metadata that an image can have, like the URL, the longitude and latitude, the width and the height. And we also tag some of our images with Google Vision. So there is a lot of other metadata that you can associate with an image, and that data actually gets stored into Elasticsearch. Again, with the data being in Elasticsearch, this is one of the dashboards that we were able to generate, telling us how much of our data is tagged with Google Vision. You could say how much of data does it have like geolocations, how much of our data has does have URLs or whatnot. But you see the possibilities, right? Like once the data is available, you can create those dashboards. We actually use Elasticsearch even during our internal search process as well. So there is a solution called as Hotel Content Hub, which uses Elasticsearch during the search process. Example, when a request comes in, it makes a call to our geo service to say, hey, for this given request, tell me the coordinates. Once that data, the metadata is available, it goes and queries Elasticsearch. And then once that data is available from Elasticsearch, then we have a domain API that applies some domain logic on top of this request and then responds back. So this is very high level. I wanted to give some of the architectures that we have, but we have a lot of more other architectures that we are using. So I want to wrap up with, before I wrap up, I wanted to talk about a few things to keep in mind, right? I think earlier Carl mentioned, and I also mentioned, that you can easily scale the instance, the cluster, by just going to the console. But when you do scale the cluster, it actually creates a new cluster. It doesn't just resize your existing cluster. The reason why I'm bringing this is when your system is already unhealthy, like there is a lot of JVM pressure or whatnot, don't go and scale the cluster. Because what's happened behind the scenes is there is a new cluster that is created and the data is just being copied from the existing one, so you'll actually increase the load on your existing cluster. What I recommend is at least wait for if there is a huge traffic that is coming to your system, wait at least for the traffic to die down and scale. If not, the other option is just scale and then pray that it just works. But I don't recommend doing that though. Even though Amazon gives you a lot of does a lot of heavy lifting on creating the cluster, scaling and whatnot, you actually have the responsibility to monitor it and optimize it, right? When you create a cluster, you could just start with T2 medium for whatever reason, or you could start with I2 8 extra large. Again, when I say optimize, is optimize on the performance, optimize on your cost, look at different angles on how do you optimize your cluster. Don't just go by the defaults that are provided and hope that it just works. This is, again, this is a wish list from my aspect. In the last, I believe, 6 to 7 months, Elasticsearch 5 version came out. Previously it was 3 something. There is no one upgrade button, right? When you go to Elasticsearch service, there is no upgrade saying go from X version to X version. You have to do it yourself, right? You have to create your own cluster. And then there are a lot of open source tools that are available, which can just pump the data from one cluster to the other cluster. But again, I wish there is, that process is also automated. The last one, if you go to the dashboard, it shows what is the free space that's available. It never talks about what is the actual space. Again, it's not a deal breaker, honestly, but sometimes it gives you like an understanding of how big the data is and just some stats around how big the clusters are. Wrapping up, I mentioned these topics, these points earlier. The biggest one, easy to set up, and then high availability. Security helps with the IP whitelisting and then the IAM access as well, and then the monitoring and backup. Because with these 4 top things that I mentioned here, it has been very easy for our teams to go and create an Elasticsearch service, like Elasticsearch cluster, and then use it for different use cases. And as it is easy, again, the adoption is significantly growing, and we are seeing new clusters being spun up almost every other day. Thanks for coming to learn about different architectures that we are using Elasticsearch at Expedia. If you have any questions, I will be here to answer.